We provide a global testing service and can offer turnkey data. We offer good value for money through efficiency and productivity. We have had at ONERA a long-term commitment with wind tunnel testing for major projects. Recently, testing strategy in wind tunnels has evolved, and I wish to illustrate that statement using Piaggio as an example. When ONERA first met Piaggio's representatives, we found that Piaggio had a new aircraft project in mind, but no elaborate strategy on how to combine CFD and wind tunnels in the design phase. We provided strong guidance on the wind tunnel testing strategy. The scheme we suggested started with a quick test entry, 4 months from go-ahead to test results, on a medium-sized full model, around 1 meter in span, using a global measurement technique, PSP, to even further simplify the model. This was followed by a number of low and high-speed tests on larger models, typically 3 meter span.
We convinced Piaggio straight at the onset of our relationship that we have the expertise to support such a strategy. We are also flexible enough to adapt our testing services to the needs of a client. But the key point in our favour is really that we have a suite of facilities able to explore the whole flight envelope of a modern aircraft. And we base our offer on a cohesive use of 3 wind tunnel facilities of world class.
Piaggio saw wind tunnel testing services as a means to reduce the industrial risk to their new product. The P1XX strategy is typical of a global wind tunnel testing services approach, using large wind tunnels, and in that respect would be applicable to many other potential customers with any type of aerospace project, missiles, airliners, UAVs, basically everything.
Wind tunnel capabilities are to me defined by 3 parameters as follows. First, the Mach number speed range. Second, the ability to assess Reynolds number scale effects on wind tunnel test results. Third, the ability to assess model deformation effects on wind tunnel test results. We have the S2 wind tunnel, which is a continuous pressurized transonic and supersonic facility with easy access capable of fast and moderate budget initial testing on typically a 1 meter span model at low and high speeds. We have the F1 low-speed continuous pressurized facility where Reynolds number scale effects can be assessed in landing and takeoff conditions. This is a critical issue in an aircraft design. The deformation effects in F1 remain moderate, with the typical span of a full model being 3 meters. We have the S1 continuous wind tunnel for high-speed testing. Full models can be as large as 4 to 4.5 meters in span, or alternatively be identical to the F1 model. This option brings a cost saving by allowing only 1 model to be used for both low and high-speed testing. S1 is an atmospheric wind tunnel and the model deformation effects are minimised in the high-speed domain. We take advantage of the large model size for maximising the number of achievable different model configurations. We believe that the suite S2, F1, S1 is fully adequate for improving the design of a new aerospace project in a stepwise mode. Ultimately, it is up to every client to decide which strategy they want to follow. The final set of data, which will allow the design to be frozen, PDR, will come from a cross-analysis amongst the 3 wind tunnels.
We have invested in the development of new testing techniques. This is what I call quality and continual improvement. An example is our ability to better correct for sting and wall effects, to perform accurate force and moment measurements, to offer a selection of state-of-the-art testing and measurement techniques, which places us ahead of others. It's important for customers to rely on a wind tunnel in the long term and build up a reliable database. I'm referring here to availability. Availability is of course attached to securing the operation of the wind tunnels, and we invest in maintenance. It's also linked to productivity, which is embedded in our wind tunnel layouts. The final aspect I want to mention is confidentiality. We value confidentiality as a top priority, and we have procedures in place.
What Piaggio appreciated more working with ONERA, among other things, was the advice they were able to provide in setting up our experimental activity based on their expertise. The suggestion they provided allowed us to set up an efficient process, which was cost-effective in terms of testing and model development. On ONERA's suggestion, we started with a small, low-cost model, scale 1 to 15, with only a movable horizontal tailplane. This model was tested at high speed in ONERA's S2 facility. The model provided us a first clue on our configuration and design performance, and also gave the possibility to validate our design process. Having this preliminary wing was then extremely useful, since we were able to modify the wing in order to test some other design solutions. There are other things we appreciated a lot, such as the proactiveness in finding solutions when model modifications were required, based on design evolution.
The future will see even tougher competition on the world market, which aircraft manufacturers will have to face. Wind tunnels will remain for years the ultimate design tool, the only one capable of reducing the design margins and, consequently, reducing risk. To that respect, the adherence to a wind tunnel use strategy can only be a corporate decision early on in a project. We provide a global testing service and can offer turnkey data. We have a policy of transparency when dealing or exchanging with clients, and we are flexible to evolving requirements. And finally, we offer good value for money through efficiency and productivity.